Today we will discuss about 7QC tool part 9 video. In this video we will discuss about histogram. So let's discuss. What is histogram or introduction of histogram? Histogram is visual tool for variable data. It organizes data or describe the process performance. A histogram is a visual representation of the distribution of a set of data. It is particularly useful when dealing with variable data, where there is a range of values. Additionally, histogram shows the amount and pattern of the variation from the process. The primary purpose of a histogram is to organize and present data in a way that describes the performance of a process. By displaying the frequency or count of data within specified intervals or bins, a histogram provides a clear picture of how the values are distributed. Histograms not only reveal the quantity of data within each interval but also illustrate the pattern of variation. Patterns such as symmetry, skewness, peaks, and valleys can be easily identified, providing insights into the nature of the data distribution. Histogram offers a snapshot in time of the process performance. A histogram offers a snapshot in time, summarizing the current state of the process performance. This visual representation allows quick and efficient analysis of the data, aiding in decision-making and problem-solving. A histogram is a graphical summary of variation in a set of data. In essence, a histogram serves as a graphical summary of the variation within a dataset. It provides a high-level overview, making it easier to grasp the key features and characteristics of the data. The principal nature of the histogram enables us to see patterns that are difficult to see in table of numbers. The graphical nature of a histogram is advantageous because it can reveal patterns that might be difficult to discern when examining raw numerical data in tables. Trends, outliers, and central tendencies become more apparent, enhancing the interpretability of the information. Means histogram is a powerful tool for data analysis, offering a visual and insightful representation of the distribution and variation within a dataset. Its graphical nature facilitates a quicker and more intuitive understanding of complex data patterns, making it a valuable asset in fields ranging from statistics to quality control and decision-making processes. Next, key concept of histogram. Data always have some variation. One fundamental concept is the acknowledgement that data inherently exhibit variation. In any dataset, there are differences or fluctuations among individual values. This variation can stem from numerous sources, including natural variability, measurement error, or inherent complexity within the system being observed. Variation have some pattern. While variation exists, it is not random or chaotic. The key insight is that there is often a discernible pattern or structure within the variation. Identifying and understanding these patterns is crucial for gaining insights into the underlying processes or phenomena that generate the data. And these patterns can be seen easily when summarized pictorially. The concept of summarizing data pictorially, as achieved through a histogram, emphasizes the visual representation of patterns within the variation. When data is presented in a graphical form, patterns become more apparent and can be interpreted more readily than when examining raw numerical values. Histograms, by organizing data into intervals and displaying frequencies, provide a visual cue to the shape, central tendency, and spread of the data distribution. In essence, the key concept of a histogram revolves around recognizing the inherent variation in data, understanding that this variation follows discernible patterns, and leveraging graphical representation to make these patterns more accessible. By presenting data visually, histograms offer a powerful means to uncover insights, detect trends, and make informed decisions based on a more intuitive understanding of the data's behavior. Next, while studying histogram, look for these 3 key points. First, location of mean of the process. Second, spread of the process. And third, shape of the process. Next, let's discuss about 4 key elements of histogram. A histogram is a graphical representation of the distribution of a dataset. It provides a visual summary of the underlying frequency or probability distribution of a set of continuous or discrete data. The primary purpose of a histogram is to showcase the underlying structure or pattern within the data, making it easier to understand and interpret. Here's a breakdown of 4 key elements and how histograms work. First element is bins or intervals. The range of data is divided into intervals or bins. Each bin represents a specific range of values. The number of bins can be adjusted to highlight different levels of detail in the data. Second element is frequency or count. The vertical axis of the histogram represents the frequency or count of observations within each bin. The height of each bar corresponds to the number of data points falling within the respective interval. Third element is continuous data. For continuous data, the bars in a histogram are typically connected because the data can take any value within a range. The continuous nature of the bars emphasizes the smooth flow of the data distribution. Fourth element is discrete data. For discrete data, each bar represents a distinct. Next, when to use histogram. The histogram graph is used under certain conditions. They are: the data should be numerical. A histogram is used to check the shape of the data distribution. Used to check whether the process changes from one period to another. Used to determine whether the output is different when it involves 2 or more processes. Used to analyze whether the given process meets the customer requirements. Next, let's discuss about how histogram works. First is data collection. Collect a dataset that you want to analyze. This could be measurements, scores, or any set of quantitative observations. Second is data sorting and binning. Sort the data and divide it into intervals or bins. The choice of bin size is important and can impact the interpretation of the histogram. Third is count observations in each bin. Determine the number of observations that fall within each bin. This count is represented by the height of the bars. Fourth is plotting. Plot the bins on the horizontal axis and the frequency or count on the vertical axis. Draw bars for each bin, with the height of each bar corresponding to the number of observations in that bin. Fifth is interpretation. Examine the resulting histogram to understand the distribution of the data. Look for patterns, central tendencies, skewness, or other characteristics that provide insights into the nature of the dataset. Histograms are widely used in statistics, data analysis, and various scientific fields. They offer a quick and effective way to visually summarize and interpret the distribution of data, making it easier to identify trends, outliers, and other important features. Next, creating a histogram involves several steps, from organizing your data to plotting the bins and bars. Here's a step-by-step guide on how to create a histogram. First step is organize your data. Collect the data you want to represent in the histogram. Ensure that your data is numerical and relevant to the variable you are analyzing. Next step is determine the number of bins. Decide on the number of bins you want to use. This depends on the range and distribution of your data. Too few bins may oversimplify the distribution, while too many bins may obscure patterns. Then calculate bin width. If your data spans a range, calculate the bin width by dividing the range of your data by the number of bins. This determines the size of each interval. Bin width range of data to be divided by number of bins. Then create bin intervals. Define the intervals for your bins based on the bin width. The first bin should start at the minimum value of your data, and subsequent bins follow at regular intervals. Then count observations in each bin. Count the number of data points that fall into each bin. This is the frequency or count for each interval. Then create a frequency table. Organize your counts into a frequency table, listing the bin intervals and their corresponding frequencies. Then choose axis and scale. Decide which axis will represent the variable of interest, usually the x-axis, and the frequency or count, usually the y-axis. Choose a scale that best suits your data. Then draw the bars. On a graph, draw rectangles, bars, for each bin. The height of each bar corresponds to the frequency of that bin. If your data is continuous, the bars are connected, creating a smooth histogram. Then provide title and label. Provide a title for your histogram that reflects the variable you are analyzing. Label the axis with the variable names and units. After making the histogram, interpret the same for result. Means analyze the histogram to understand the distribution of your data. Look for patterns, central tendencies, and any other features that provide insights into your dataset. You can use various software tools to create histograms, such as Microsoft Excel, Python, using libraries like Matplotlib or Seaborn, R, or other statistical software. Remember, the effectiveness of a histogram depends on thoughtful choices in bin width and the number of bins, so experiment with these parameters to find the representation that best conveys the characteristics of your data. Next, how to create histogram with example. First, obtain or collect a set of 50 to 100 observations. Here capital N denotes total number of observation. Then find the maximum value and the minimum value in the collected data. Then determine number of classes, which is denoted by capital K, which is equal to square root of capital N means number of observation. Then find class width, denoted by small c, which is equal to maximum value in data set minus minimum value, and the result will be divided by number class value, which is K, remember, always rounded off to a convenient value. Then calculate the lower class boundaries, which is equal to minimum value minus half of class width K, and this result will be the starting point. Then calculate the upper class boundaries, which is equal to maximum value plus class width K, it will be the end point. Then make a frequency table, that is, number of data falling in each class. Let's see in details. A shaft manufacturer have to go for quality improvement. He wants to know what is his process pattern. Here specification value is 10.75 plus minus 0.05. These are 50 observed data of outer diameter of shaft. means capital N is equal to 50. Then obtain the maximum value, which is 10.82 and minimum value 10.72. Determine the number of classes K which is equal to square root of capital N means total observation. Result of square root of 50, which is approx 7. As you have to take round off value. Then calculate class width means small c value, which is equal to maximum value in the data set minus minimum value in the data set, and the outcome will be divided by class width means capital K means small c is equal to 10.8 to minus 10.72 means 0.01 to be divided by 7, and the result is 0.014, but take round up value 0.02. Then calculate lower class boundary value. As per formula, minimum value in the data set to be subtracted by half of class width. So ALCB is equal to 10.71. Note here always take lowest value in between specific lower limit value 10.70 and lower class boundaries value which is 10.71. Then calculate upper class boundaries. As per formula, maximum value in the data set plus half of class width. After calculation, UCB is equal to 10.84. But take highest value in between specific upper limit value and upper class boundaries value. Next, make a frequency table that means arrange data in each class which is range of 0.2. In our example, lower class boundary is 10.70 to 10.72. Because you have to make a range by adding 0.02 in LCB. Likewise calculate other range or class. In this range, one data point available. Means frequency is 1. Next step. Make a histogram chart considering shaft diameter range value in x-axis and frequency in y-axis. If you closely analyze the histogram, you will find 3 data points are fall above upper specification limit. USL. Next, types of histogram are: first, normal distribution or symmetric histogram. Second, twin peak type of bimodal histogram. Third, plateau type. Fourth, comb type. Fifth, cliff pattern. Sixth, isolated peak type. Let's discuss one by one. Next, normal distribution. A normal distribution histogram represents a bell-shaped curve, indicating that the data is symmetrically distributed around the mean. A normal distribution, also known as a Gaussian distribution or bell curve, is a statistical concept that describes a symmetrical, bell-shaped probability distribution of a set of data. In a normal distribution, the majority of the data points cluster around the mean average, and the distribution is characterized by its shape, which is determined by the mean and standard deviation. The standard normal distribution has a mean of 0 and a standard deviation of 1. Next, twin peak type of bimodal histogram. A bimodal histogram has two distinct peaks, suggesting the presence of two different modes or patterns in the data. A bimodal histogram is a type of distribution that exhibits two distinct peaks, indicating the presence of two different modes or patterns in the data. Each peak represents a mode, which is a high point of frequency in the distribution. Bimodal distributions suggest that there are two separate groups or subpopulations within the dataset. Next, plateau type. A plateau type histogram may have a flat or plateau-like shape, indicating that the data has a relatively constant frequency over a certain range. A plateau type histogram has a flat or plateau-like shape, indicating that the data has a relatively constant frequency over a certain range. This suggests that there is a consistent level of occurrence for the variable being measured within that range. Plateau-type distributions may indicate a stable or uniform pattern in the data. Next, comb type. A comb-type histogram may exhibit alternating high and low frequencies, creating a pattern that resembles the teeth of a comb. A comb-type histogram exhibits alternating high and low frequencies, creating a pattern that resembles the teeth of a comb. This suggests periodic or cyclic patterns in the data, where values occur with regular intervals. Comb-type distributions may be observed in data with repeating patterns or cycles. Next, cliff pattern. A histogram with a cliff pattern may have a sudden drop in frequency, creating a step-like appearance. A histogram with a cliff pattern may have a sudden drop in frequency, creating a step-like appearance. This indicates a sharp decline in the occurrence of values, possibly suggesting a distinct boundary or change in the nature of the data. Next, isolated peak type. An isolated peak in a histogram suggests an outlier or a single data point with significantly higher frequency compared to the rest of the data. An isolated peak in a histogram suggests an outlier or a single data point with significantly higher frequency compared to the rest of the data. This peak stands out from the overall pattern, indicating a potential anomaly or extreme value in the dataset. Identifying and understanding isolated peaks can be important for recognizing exceptional cases or errors in the data. These descriptions provide a qualitative sense of the shapes and patterns that histograms can exhibit. Each type of histogram pattern can provide insights into the characteristics of the underlying dataset, helping analysts and researchers understand the distribution and behavior of the data. It's important to note that these types are not exhaustive, and histograms can take on various shapes and patterns depending on the nature of the data. Next, let's discuss about difference between bar graph and histogram. In case of histogram, it is a two-dimensional figure. But in case of bar graph, it is a one-dimensional figure. In case of histogram, the frequency is shown by the area of each rectangle. But in case of bar graph, the height shows the frequency and the width has no significance. In case of histogram, it shows rectangles touching each other. But in case of bar graph, it consists of rectangles separated from each other with equal spaces. Hope you understand histogram. Thank you for watching our video. Subscribe